Okay, in this lecture video, it's a follow-up to what happens when compounds dissolve. And what we saw was that when an ionic compound dissolves, it breaks apart, it dissociates into its individual cations and anions. And those cations and anions are then free to float around the solution. So the example that we looked at last time was when you take solid sodium chloride and you put it in water, you end up with aqueous, so dissolved sodium cations, and aqueous or dissolved in water chloride anions. And we call this new solution now an electrolyte, because as these ions are free to float around the water, they can carry an electrical current with them. So we refer to these solutions as electrolytes. Another example then would be hydrochloric acid molecules. Now this is a little bit different. So sodium chloride, the ionic compound we just looked at, had ionic bonding. It was composed of cations and anions. Hydrochloric acid, on the other hand, is a covalent compound. But that doesn't change the fact that when it is dissolved in water, as shown here, it breaks apart into aqueous H plus cations, which are also called protons, because a hydrogen atom that has lost an electron to become positively charged only has a single proton left, so it's a proton. So hydrochloric acid molecules dissociate into H plus cations and chloride anions, again, that are aqueous. So in both of these cases, the molecules, whether they were ionic or covalent, completely broke apart from one another into individual ions that were free to float around the solution. And because they were free to do that, they could carry an electrical current. So these are both types of electrolytes. But not all covalent compounds dissolved in solution function as electrolytes. Some of them are in fact non-electrolytes. So in this example, we're looking at sugar molecules. So here we can see sugar molecules dissolved in solution, and they're staying completely whole, right? There's been no breaking apart into cations and anions. Over here, we're looking at an ionic compound solution again. This is our sodium chloride example. And you can see in this solution we have individual cations and individual anions. So over here we have no charged species, right? So the molecule has stayed completely together. It's covalently bonded, so all of the atoms are sharing electrons. There are no ions present. But it's still dissolved in. And so this is sort of a zoom out picture of another non-electrolyte molecule dissolved in solution. So this non-electrolyte is again covalently bonded, and I can circle them here in green. So here they are, just floating around in the solution, and they are surrounded by all of these water molecules. And these water molecules are still interacting with the dissolved solute. They're interacting through forces like hydrogen bonds, which we talked about before. So you still have interactions between the solvent and the solute, but we don't have charged particles, and we don't have it such that the molecules themselves have broken apart. They've stayed whole. So of course we have electrolytes where they break apart completely. We have non-electrolytes where they stay completely together. And then of course we're going to have in between. So acetic acid here is an example of a weak electrolyte. So in acetic acid, if we wanted to write the chemical equation representing it dissolving in solution, we would write CH3 COOH. That's the formula for acetic acid. And I might be writing it a little bit different than you're used to, but it's still acetic acid. And when you dissolve it in water, this covalently bonded molecule breaks apart into aqueous protons and the acetate ion, which is just one of our polyatomic ions, and it's also aqueous. But if you look over here in our example where that acetic acid is dissolved, you can see that most of the acetic acid molecules have stayed together. So all the ones that I'm circling here in yellow have stayed together. So those guys represent this molecule. Whereas in green, I'll circle the products of the dissolving process, which are H plus and acetate. So in this case, what we see is most of the molecules, so here's the products, most of the molecules have stayed together in this form. So it's a form that's not ionic, it's the whole molecule. So this form in yellow is a non-electrolyte, while the forms in green are the ions that can serve as electrolytes. So since most of the solution is non-electrolyte, we call this solution as a whole a weak electrolyte solution. So this kind of talks about the difference then between electrolytes, weak electrolytes, and strong electrolytes, and what's happening during the dissolving process.